Hello, it's Keith here, and this is lesson 22 of the simple series of my Z80 programming tutorials. We're back on the Amstrad CPC, the system I grew up with, and today we're going to be looking at drawing software sprites on the screen. We had an example before where we had a Chibiko bitmap, which is my mascot, and it could move around the screen, and we have a very similar example here today, but this example has been changed and it allows for sprite clipping, so the sprites can be partially or even entirely off the screen, and this sprite clipping is occurring on all sides of the screen, top, bottom, left and right. So this is basically the kind of code you might need if you're making a more complex game where your graphics can go partially off the screen, and this was something that Chibiko did, although there was a bug in that game, and also Suck Hunt, my stereoscopic 3D game on the Amstrad CPC. This code is directly taken from that, although that game only cropped left and right. It didn't need to crop the top and bottom, but I modified the code. Now we're going to be looking at this in two episodes. The first episode we're going to look at the clipping code and the basic sprite drawing. The second episode we're going to go into more detail. We're going to look into the page flipping, and we're also going to look at some stack misuse, which is being used to speed up the drawing. The other thing you'll notice is we are changing the screen size on the Amstrad CPC. We're changing it to 256 by 192, which is the more common screen size for the other systems if we're doing spectrum porting and things like that. It also allows us to make our games a little bit faster, a little bit less screen space, a little bit faster games. So yeah, it's worth considering in general, and that's another thing we'll be looking at next time as well. So today we're going to look at the basic code and the clipping code. First of all though, let's go over to our theatre screen and let's discuss the logical units that I use in my games these days. So what's the problem we were looking to solve? Well, quite simply put, we want to work in byte values for X and Y coordinates because our system's 8-bit, it likes working in bytes, not so much in 16 bits. Now the problem is if we've got a 256 by 192 screen and we also need to have coordinates that are partially or entirely off the screen, we need to have a coordinate system that allows for off-screen areas. So I use a very simple format. Basically, I just use logical units where one logical unit is 2 pixels. So basically, we're just dividing our X and Y pixels by 2 to get logical units. So the visible screen in logical units will be 128 logical units by 96. That's 256 by 192 pixels. And the start will be 64,80, and it will go down to 192 by 176. And if we had a Chibiko bitmap in this position, only this top right corner would be visible on the visible screen, and so that's how our cropping is going to work. Okay, so that's how our logical units work. Now let's discuss the cropping algorithm that I'm using in these tutorials, and I've ported the same one to a wide variety of systems. Okay, so if you imagine that this is our screen, that is our screen, even though it doesn't look very square, it is our screen. And this is the sprite that we want to crop. Okay, so our sprite is going to move around the screen, and there it goes, it's moving around the screen. But then when it goes off the screen, we're going to need to change it. We're going to need to remove some parts. So if it goes off the top of the screen, we're not going to need to change the height, and we're going to need to skip this part of the source data. That's if it goes off the top of the screen, but if it goes off the bottom of the screen, we're going to need to just change the height. So we just need to change the height to this part here. If it goes off the left-hand side of the screen, well, we're going to need to do a few things. We're going to need to change the width. We're going to need to skip this part of the source data before the first line. And then after the next line, we're going to need to skip this part because we're going to draw our bitmap horizontally from left to right, so we would need to skip part before we start drawing at all. If it's off the right hand side of the screen, well, we're going to need to just change the width, and then after each line we're going to need to skip this part. We don't need to skip any at the start. The challenge, of course, is there's no reason that our sprite couldn't be off multiple sides, so we might need to do multiple things, and that's where that bug in Chibiko came in, because Chibiko couldn't do it right. There was a bug in it, and it would corrupt the sprites if they were off 2 sides at the same time. So if you want to look at my code and mock me, then you're welcome to do so. Okay, well, let's go over to the source code and let's see how all of that comes into play. Okay, so we've got some variables here we're defining to define the top coordinate of our screen and the width and the height of our screen in logical units. We are setting up our screen here. We've got these CRTC values here, which are the screen settings to define our 256 by 192 screen, and you can see them all here. They're very exciting there. So these are just some generic values you can use to set up the screen. Now, as I say, there are some tricks going on here. There's some screen buffering, so we're flipping between two buffers, and we are able to use hard stack misuse to accelerate the sprite, but we're going to look at those next time. From the point of view of today, we're just going to look at this draw sprite routine, the basic draw sprite routine, and we're going to discuss how we're cropping it. So how do we do it? Well, we're loading IY with the bitmap source data, and we're loading H and L with the width and the height of the sprite in logical units. So 24 by 24 means 48 by 48 pixels. We're then running this do crop routine, which is going to set the carry flag if the sprite is entirely off the screen, in which case we return. Okay, if we are going to draw the sprite, then we are running get screen pos, and then we're running this show sprite routine. So first of all, let's take a look at this cropping routine. When we run this routine, X and Y is in BC, so B is the X position and C is the Y position. The width and height are in H and L. H is the width, L is the height, and the source bitmap is in IY. And D and E are used as temporary variables throughout. So what we're going to do to calculate the crop is we are first going to take the Y position of our sprite, load that into the accumulator, and subtract the minimum Y. Now, if our sprite is partially off the top of the screen, this is going to go into a negative value. If not, we don't need to crop the top of the sprite, so we're just skipping over. But if we do need to crop, we're converting that negative to a positive and seeing if it's the entire height of the sprite. This would mean that our sprite is entirely off the screen, and in that case we don't want to do anything, in which case we're jumping to all off screen. All off screen is setting the carry and returning. Okay, so that's what we're doing if there's nothing on the screen. Now, if there is something on the screen, well, what we're doing here is we're storing that in E for later on. That's the amount we need to remove from the top, and we're setting the Y position to 0. So we're resetting the accumulator here and storing whatever the new accumulator is in C at this point. Now, if we didn't need to crop, we did need to subtract the minimum logical units, so we're one stage closer to getting that to a pixel Y position. Okay, now we're going to crop the bottom, so we're adding the height of the sprite and comparing that to the height of the screen in logical units. And if we're partially off the bottom of the screen, then we're going to need to see if we are entirely off the bottom of the screen, so maybe our sprite's all the way down there. Again, we're comparing to the height, and if that's greater than the height, then we're entirely off the screen. Otherwise, the value we've got here is the amount to remove from the bottom. Okay, so we've got the amount to remove from the top in E and the amount to remove from the bottom in D. So we're adding those two together and seeing if the result is not 0. If it's not 0, then we're negating that and adding that to L, and that is the new height of the sprite. So the height of the sprite factoring in the top and the bottom crop. Now, what we're doing next is we are taking E, the amount to remove from the top, and we are going to see if we need to remove anything from the top of the sprite, because if we do, then we will need to skip some of the bitmap data if our sprite is partially off the top of the screen. We are taking the number of bytes per line in E, and we're taking the number of lines we need to remove into the accumulator here. And what we're going to do is we're going to repeatedly add DE with D as 0, effectively subtracting the number of bytes in each line in logical units from the source bitmap data, and that's going to handle that top crop. Now we've finished the cropping vertically, so we're now going to crop horizontally. What we're doing here is we're zeroing D and E again, and we're going to do the exact same thing for the left and the right. Now here we're taking the X position into the accumulator, subtracting the minimum logical X position, and again, if that has not caused a carry, there's nothing to remove from the left. If it has though, we've gone negative, so maybe our graphic is somewhere like this, maybe it's somewhere like that, in which case we're converting that back to a positive and comparing to the width. If we're over the width of the sprite, there's nothing on the screen. Otherwise, we're now doing some conversion here, and then we're doing this because the screen on the PC works in 4 pixels per byte, but our logical units are 2 pixels per byte, so we're rounding up here by adding 1 here. And then what we're doing here is we are now, if this use stack misuse is defined, we're converting this to a number of pairs of bytes, and that's because if we're using stack misuse, we're working in pairs of bytes here. So that's why we're doing that if use stack misuse and it's enabled. Anyway, we've now calculated our X position for the drawing. We're now going to add the width of the sprite and subtract the entire width of the screen and see if any of our sprite needs removing if it's partially off the right hand side of the screen. If it's not, then we are jumping and skipping over the next bit, but otherwise we're seeing if the amount we need to remove is greater than the entire sprite, and again if it is, we're giving up. Otherwise we're storing that value in D. Okay, so we add D and E, the amount removed from both sides. We're converting that to a number of bytes by shifting it to the right ones, because as I say, we're working in logical units which are pairs of pixels, but the screen works in 4 pixels per byte. So we're converting this to a number of bytes. And if we are using stack misuse, we actually need to convert that to a number of words. So that's the minimum X coordinate we can work in. If that's resulted in 0, we're giving up here. Otherwise, we're storing this as sprite h clip plus 2. We're using self-modifying code here to patch this into the destination drawing routine, and this is the amount of data we need to skip after each line of our sprite if our sprite is partially off the left or partially off the right. So that's what we're doing there. And then what we're doing here is we are calculating the new width. So we're checking one last time to see if we are effectively removing the entire width of the sprite, and if not, we are now storing that back into H, and so that's factoring in the amount to remove from both sides and converting to bytes as required. So that's our final width in logical units. What we're now doing here is we are going to take E, which is the amount to remove from the left, and we're going to basically skip any bytes from the left hand side. Now if we are having to clip our sprite on the sides, we're actually going to use a different version of the program. We've actually got 2 versions of our get next line routine. A fast one for if our sprite is entirely off the screen, and a slow one for if the sprite is partially off the screen. So we're using self-modifying code to patch in the correct version here. And then what we're doing here is we are calculating the number of bytes that we need to skip before the first pixel if our sprite is off the left hand side of the screen. And that's what we're doing here, and we're adding that to IY here because IY is our source bitmap data. Okay, if we don't need to do any horizontal clipping, we're setting the default get next line routine here. The final thing we're doing here is we're converting our logical units to the physical ones. Our horizontal units are in bytes, 4 pixels per byte, so we're dividing the X position and the width by 2 by doing a shift to the right to convert them to bytes. We're converting our Y position and our height from logical units to lines, so pixel lines. So we're multiplying that by 2 to convert that. And then we're clearing the carry flag with an OR8 and we're returning. Okay, so that's how we are doing our cropping. And now we've got our calculations done and we're ready to actually show our sprite. So we will now return here. We'll run get screen pos, which is calculating the VRAM destination, and then we're running our show sprite routine. Now I'm not going to really go over the calculation of the VRAM destination. It's a little bit complicated. Here it is. We've covered it before in the simple series, so if you're not willing to accept that it just works, then please see that other simple series example, because I don't want to discuss it all again. Okay, so that's how we're doing that, and then when it comes to actually doing our show sprite routine, let's take a look at that, because that has actually changed. Okay, so here is the show sprite routine here. Our source data is now in DE, that's our bitmap source, and our destination is in HL, and we're using an XOR sprite, which means if we draw it to the same position twice, it will disappear. It's just a convenience, although actually this version is using double buffering and it's clearing the screen every time. But I left the XOR code in because I thought it was an easier way to keep this example as very flexible as possible. Okay. So what we're doing here is we are going to transfer all of the lines to the screen. So basically we are loading a byte from our source bitmap, XORing it with the screen and writing it back to the screen, incrementing our DE destination and incrementing just L of the screen destination, because we're using a 256 by 192 screen, this byte aligns our screen and we don't need to increment H and L of the screen memory, and that's another reason that there's a good speed increase with using this smaller screen, so definitely worth considering. We repeat until we've done an entire line, and then we're going to jump to our get next line routine, but this will be modified by self-modifying to code if we need to crop. If we don't need to crop, then basically we're just adding 800 to our HL pair which I'm doing by adding 8 to our H part. If bit 7 hasn't been flipped, because that's part of our screen base, then we don't need to do anything else. But if it has, then we need to add CO40 because the screen memory is a bit odd and it's kind of interlaced. So every 8 lines we need to jump back up. So that's what this is doing here. It's a bit of a pain, but that's what we're doing there. Now that's the regular version, but if the sprite is partially off the screen, there is something else that we need to do. We need to skip over any bytes, turn around Chibiko, any bytes that are partially off the screen. So in this position, we need to skip the bytes at this left-hand part, and that's what this get next line with clip routine is doing. And this will be self-modified in, and it will be, this jump will be changed. Okay, so what we're doing here is we are adding H and L, which will be modified by self-modifying code with the number of bytes that we need to skip after each line when the clip is occurring. So we're adding that, and then we're falling into the get next line routine. And that's all there is to it. A little bit complicated, I know. So there we go. So that's all we're going to be discussing today. As I always say, you can go to my website and download the source code and the build scripts and all that exciting stuff. If you liked what you've seen today, please like and subscribe, because next time we're going to be looking at this code again, and we're going to be looking at that stack misuse code, and we're going to be learning how the stack misuse works to allow the code to be faster. And we're also going to be learning about the screen buffering to work out how the page flipping works. I hope you've enjoyed this today. Thanks for watching, and goodbye.